All right, so for measures of variation, we start with the minimum of the data set. It's self-explanatory. On a spreadsheet, it is just min, parentheses, and then locate your data. Maximum. That is just on a spreadsheet, max data. Based on the min and the max, we can find what's called the range of the data. And that's just the max minus the min. There isn't a spreadsheet function for range. You have to calculate the min, calculate the max, and subtract them. You could do it in 3 lines like this, or you could do it in a single line, kind of like just the blue part there. Standard deviation. Now, standard deviation is one way to find the average spread. It's the most popular. It's the most useful. So it's a measure of the average spread from the mean. That's super important, that from the mean there. Now, what letter did we assign to the mean earlier? We assigned the mean the letter X with a bar over the top. So last week, I was home sick. I wasn't feeling good, and I did my class from my basement. I had a slight temperature. My temperature was about 100.5. Now, that's high. Usually we expect somebody that's healthy to have a temperature about 98.6, but individuals have there's variation about what an average temperature is among individuals. And then throughout the day, your body temperature changes. Okay. But we have this idea that 98.6 is normal. If you measure above that, that could be a problem. If you measure significantly below that, that could be a problem. So my body temperature the other day wasn't average. Now, again, if I take it today, it's going to be something different. Typically, I come in at around 97.5 is my typical body temperature. For some reason, I measure cool. X is an individual's measurement. I want to know how far I am from the mean. So that would be X minus the mean. Right? Example is me the other day. I had a temperature of 100.5. The average body temperature is 98.6. If I subtract those two, then what do I get? I get a temperature of about 1.9 difference. That difference between an individual measurement and the average measurement, that's called deviation. Now, typically, I'm below average, right? So another example, I mentioned that typically I'm around 97.5 if I'm just resting. If I take that away from take the average away from that 98.6, in this case, I'm subtracting a bigger number, so I get what? Negative 1.1. I did that right. I'm a little below average. So a deviation is negative if you're below average and positive if you're above average. Okay. Sometimes it's good to be above average. Sometimes it's not, right? You don't want to be too far above average with temperature because that's dangerous. Next, if I calculate everybody's deviation, I want to try and average them because I want to know what's the average distance from the mean. Now, the problem is the way average works, if you add up all the deviations, it's always going to add up to 0 because the mean is the middle of that idea. So to have it not add up to 0, what we do is we square these numbers next, and then we average them out by dividing by how many there are. Remember, n is the sample size. So we take the deviations, we square them, we divide by n. Okay, so now I have the square of your difference from average body temperature. What the heck is the square of a temperature? I know what square feet are. I'm not sure what square degrees are. How do you get rid of a square? You take a square root. Okay, so after I found the differences and squared them, oh, I forgot, I got to add them all up. Remember that symbol for add shit up? Then I divide by how many, that gives me kind of an average, but then I got to get rid of the square, so I take the square root of all of this. This is how you calculate standard deviation. I would appreciate it if you would never do this by hand. You can, it's a lot of work. Spreadsheet does it better. So again, put it in a little bit more words. I sum the squares of the deviations. I divide by how many there are, and then I take the square root of that whole beautiful thing there. I'd like you to memorize that by Wednesday, please. Just kidding. We're never going to do that by hand. What we're going to do instead is on the spreadsheet, we're going to go equals STDEV dot S. And then we're going to tell the spreadsheet where our data lives. Please, please, please don't do that by hand unless you really dig calculations like that. So that's something you can add them all up, right? This symbol right here means add them all up. Yeah, so that's it's the capital Greek sigma. So this right here is capital Greek sigma. And it means to sum. Add them all up. Okay, what are the important things here? Important thing here, there's a spreadsheet formula. Other important thing, I'm not going to count it as a summary statistic, but it is an important idea. To find the standard deviation, you need to find deviation. And deviation is just distance from the mean. Right? Like for average height of guys in the US, I'm a little below average. Some people are above average. Deviation is just how much below or above average are you? That's just deviation. And in terms of figuring out, trying to describe for a big set of numbers, how spread out are these numbers? Standard deviation is the most popular statistic to describe the average spread of the numbers. And it's not just average spread, it's average spread from the mean. So you can't talk about standard deviation without talking about the mean too. They have to go together. Now on a spreadsheet, can you find standard deviation without finding the mean first? Yeah, the spreadsheet's going to do all of that for you. All right, so just to demonstrate, I'll go over to my spreadsheet here and do it on these numbers. I repeat, I'm not going to do standard deviation by hand. I think it's a waste of time. We just got to get used to the idea. So here I found the average right there. I'm going to delete it so it's not on the screen. And then underneath here, I'm going to put a little space. I'm going to write STDEV just as an abbreviation that I'm calculating the standard deviation. And then next to that, I'm going to go grab the formula. So equals, start typing ST for standard. There's a ton of different standard type formulas. We want the one that has the .s. This is very important. The other ones will probably give you different answers that are not relevant. We want the .s. What does S stand for? S stands for sample. This is the standard deviation of a sample. Got to have that .s. And then you just go to your data. Mine's in column A, so I'm just going to say, hey, column A right there. Now notice the mean is not on the screen anymore, right? The spreadsheet does all of that calculation for us. It figures out what the mean is. It subtracts every single number from the mean. It squares them, it adds them up, it divides by how many, and then it takes the square root. It does all of that for us in the background. Boom, there's the number. All right, I'm going to put the mean back in there. Mean is average. Grab my data again. My mean was about 26. All right, what should I round the standard deviation to? Well, since my ages are all whole numbers, then I should take it to 1 decimal place. So again, that's the rounding rule. If you're not told what to do, often the homework assignment will have a rounding estimate or something to do for rounding in there. So I'm just going to drop this down to a single decimal place. Oops, too far. There we go. All right, so for this set of numbers, the average age is 26 with a standard deviation of 9.4. What is the 9.4? It's on average the spread from 26. So it turns out within usually, now let's draw this on a graph so I can explain it more. I have to zoom out for that. Didn't I do an age histogram somewhere? Where'd it go? Yeah, I must have deleted the graph. Yeah. Yeah, so back to the notes too. So in the notes, again, it's anytime you do a command on the spreadsheet, it's equals. We want steev.s parentheses and then go find your data. Just select your data wherever it is. And there's several ways to select data. So let's delete that, start over. So equals, start typing ST, and it says there's a bunch. Now there is one that's just called standard deviation. That is probably going to disappear from most computers because there are many different standard deviations, and S is the safer one to do. Never do the P. P means you have every single number in the population, which we never have. Okay, so it's in there for whatever reason, but you almost never have a reason to use it. We want the .s, and then all I have to do is grab my data, and I can do that by selecting the column the data is in, or individually selecting all of the numbers by clicking and dragging. And either way, I should get the same answer. And again, if you select blank cells, it's not a big deal. Standard deviation, like some of the other calculations, ignore words and blank cells. So close the parentheses, hit enter, and you should get 9.4 like I did before for this set of numbers. Okay. All right, next I want to see that graphically. So I'm gonna zoom out. I need a histogram to show what this means. I'm gonna grab my data. I'm going to make that graph again, insert chart. And I want a histogram. And I'm going to group by customize histogram. 5 I thought was nice here. That's beautiful. All right, and this is just missing a, let's see where titles. Horizontal axis. Oh, no, vertical axis is missing. All right, I could call it frequency if I could spell. What's a better name for frequency here than frequency here? Number of students would probably be better. All right, so I'm going to use the graph to graphically show what standard deviation is. Screw that up one more time. New page. All right, so remember for this data set right here, and I'm going to round this just a little bit to make it easier. My mean X bar was 26, and the standard deviation, I'm going to round that to a whole number. The computer said it was 9.4. I'm going to use 9 because that's going to be easier for me to draw this out. So standard deviation, what is it again? Standard deviation is the average distance from the mean. So to graphically show what standard deviation means, you got to find the mean. Well, here's 25, there's 30. So the mean's about right here. X bar 26. So on average, people are about 9 years away from 26 either way. So 9 above 26 would give me what, 35? So this right here, 35, is 1 standard deviation above the mean. from the 26, if I subtract 9, that's going to give me 17. So if that's 20 and that's 15, 17 is going to be about right here. So this would be 17, and that would be 1 standard deviation below the mean. Now, there's nothing special about being 1 standard deviation above the mean. Somebody could be 30 years old, which means they're like a half a standard deviation above the mean. They're not a whole one. I could be 2 standard deviations above the mean. So if we add 9 to 35, that would give us 44, right? That'd be about here. So 44 is 2 standard deviations above the mean. And we could go the other way. We subtract 9 from 17, that's going to give us 8, kind of off the chart here, but I'm going to put it in anyway. So 8 would be 2 standard deviations below the mean. For most data, what we're going to find, so here I have from 8 is 2 standard deviations below, and 44 is 2 standard deviations above. About 95% of values are within 2 standard deviations of the mean. So in this case, let's see, there's probably what? Maybe 5 here, maybe 10 there. So I'm going to guess there's like 17 people that I've had in this survey that are above 44. Maybe it's as high as 20. So that means if there were 306 numbers before, then we take away around 20 from them. That's going to give us what, 286 out of around 306, roughly. We could look at the data and actually check it. Are you always going to get exactly 95? No, it's going to be more or less. So what would that be? If it was 286 out of 306, that would be 93% roughly. Will there be some data sets that kind of blow off that rule? Yeah, weird stuff happens. But for most data sets we see, what we're going to find is about 95% is within 2 standard deviations. As far as within 1 standard deviation, that's much more variable than data, and I'm not going to make a statement about that. But this gives us a sense of the average spread from the mean. It's called standard deviation. We should use a spreadsheet to calculate it, although you could do it by hand if you really want.